Welcome to our final recording in our series on quadratic functions in vertex form for Unit 3, Chapter 3 of Quadratic Functions, Mathematics 2200. We're going to model problems using quadratic functions in vertex form. Y equals a outside of x minus p squared plus q. So we're going to bring together a few of the skills that we've learned in the last few recordings. Example 1. Suppose a parabolic archway has a width of 280 centimeters and a height of 216 centimeters at its highest point above the floor. Write a quadratic function in vertex form that models the shape of this archway. One of the keys to these problems is to place the diagram on a coordinate system. And you really want to place or be strategic about where you place the origin right here. Okay, so for example, if I just choose some random location like that, that's not going to be very helpful. But on the other hand, if I choose a location like this, that's pretty helpful because I've got enough information here, but the width of the archway right here to come up with the p-value, the x-coordinate of the vertex, and the total height to get the q-value of the vertex. Another convenient location might be to put the axes right with the origin right at the vertex. That's another possibility as well. I think I'll stick with the first one. So I know this distance here is only 140 because it's half of the 280 for the width of the arch. And therefore, I now know my vertex, my p and my q values are 140 and 216. So I follow the procedure outlined in recording number 1E of this series. We begin by writing the vertex form y equals a outside of x minus p squared plus q. And therefore, we know the p and q value, so we have y equals a outside of x minus 140 squared plus 216. Now we need another known point on the graph. Well, because I've conveniently placed my axes like this, I've got a point 0, 0 that's on the graph. So we'll substitute 0, 0 for x and y. So I've got 0 goes in for my y, and 0 also goes in for my x. So I've got 0 equals 19,600 times the value of a, because I get negative 140 squared here. That's 19,600 plus 216. A little bit of rearranging. Negative 216 equals 19,600 times the value of a. Divide both sides by 19,600. The fraction simplifies to negative 27 over 2450 for the a value. So our function is y equals negative 27 over 2450 outside of x minus 140 squared plus 216. Now, part B asks us to determine the height of the archway at a point that is 50 centimeters from its outer edge. So here's the outer edge, 50 centimeters from that. We're looking for the height of the archway. So 50 is a value of x. And that works out to approximately 126.7 meters high. This next example is about a bridge. The deck of a bridge is suspended from two main cables attached to the tops of two supporting towers. And here they are. Between the towers, the main cables take the shape of a parabola as they support the weight of the deck, and the deck being the part that the cars are driving on. The towers are 111 meters tall relative to the water's surface. It's 111 meters up here and 111 meters up here. And they are 472 meters apart. The lowest point of the cables is approximately 67 meters above the water's surface. Right there. Model the shape of the cables with a quadratic function in vertex form. To help us understand the problem a little bit better, I've put some of those values right here on the picture. We'll transfer them to a graph. Okay, I've drawn my own sketch of the towers and the cable, and I need to decide where I'm going to place my axes. I could, for example, go up here. I could go something like this. But I think I'll go like this, which is the water level. So because the towers are 472 meters apart, I know my vertex halfway between the towers. So it's 236. I have a height above the water here of 67. So my vertex is at 236 and 67. And I'll need another point. And a nice easy one here is at 0 and 111. So as in the previous example, I take my vertex form, substitute in my P and Q values, and I'll need 0 and 111 to substitute in to get my A value. So I've substituted in here. I've gotten this far. So rearranging a little bit, the 67 comes over here, subtracts. I'm left with 44 equals 55,696A. Therefore, once we get our A value, we can write our function. To conclude, when modeling a problem, sketch a diagram if possible. Use the diagram and given information to determine the location of the vertex and at least one other point on the graph. And then use the 3 steps from recording 1E to get the function.